Today we are talking measurement. We have two systems that we use to measure things. We have the U.S. customary system and we have the metric system. Obviously, we don't use the metric system in the U.S. very often, but everyone else uses it, so it's important to know. So today we're going to start talking about metric system. In the metric system, we have three different units that we can measure in. We have grams when we talk about weight. We have liters when we talk about capacity, and we have meters when we talk about length or distance. All right? And then this stays very consistent. We have this little story that we can use to remember, and it stays consistent between grams, liters, and meters. So we have King Henry died unexpectedly drinking chocolate milk. Okay? K stands for kilo. H stands for hecto. D stands for deca. U stands for unit, and that's basically one of these three things, the meter, the liter, or the grams. This D stands for deci, centi, and milli. Okay, so if we're talking grams, this is kilograms, hectograms, decagrams, grams, decigrams, centigrams, milligrams. Now, if we were to say that we had 1 gram, we get smaller as we go this way, okay? And we get bigger as we go the other way. So milli is the very smallest of all of these measurements, and kilo is the very biggest. So if we have 1 gram, that's equivalent to 10 decigrams. Now, it takes more decigrams to measure the same amount of weight because decigrams are smaller, which is equivalent to 100 centigrams, which is equivalent to, man, these don't want to do lines for me, 1,000 milligrams. Okay, so as we're moving this way, basically, we've multiplied by 10, multiplied by 10, multiplied by 10. Now, if we're going this way, though, we're getting bigger going this way. So we're actually going to divide by 10 because decagrams are bigger than grams, so we need fewer of them to talk about the same. So this is 0.1. 0.1 decagrams. We're going to put DAG. That way we can tell the difference between decagrams and decigrams. Then we have 0.01 hectograms and 0.001 kilograms. So now we've been dividing by 10, dividing by 10, dividing by 10. Now, if we started at kilograms and worked our way down to milligrams, we would multiply, and to go milligrams, we divide. We just started in the middle, so we were multiplying one way and dividing the other way. But like I said, this is consistent for grams, liters, and meters. So instead of G, we could put an M for meters and then put decimeters, centimeters. Do the same thing for liters. We always capitalize the L in liters, like when we're talking kiloliters, we'd write this. That way we can tell the difference between L's and 1's. Okay, so now that we understand that, we're going to remember that little story, King Henry died unexpectedly drinking chocolate milk. And we're going to move on to our first problem of the day. So basically, we're going to be given, a measurement, 7,500 millimeters. How many decimeters is in that? So if we draw, aren't you working? Why aren't you working? Let's try this one. There we go. King Henry died unexpectedly drinking chocolate milk. Okay, so they're telling us that 7,500 milliliters. How many decimeters is that? So we're trying to find an equivalent ratio, basically, if it's 7,500 millimeters, how many decimeters in it? So we know that if we're going to the left, our units are getting bigger, so we actually need smaller numbers to talk about the same distance. So we're going from here, which is a divide by 10, and here, which is a divide by 10. So we're going to take 7,500, we're going to divide it by 10 twice. And the easiest way, we call it bloop-de-blooping in my class. I know it's a very scientific word. We're going to move our decimal. We know that when we divide by 10, our decimal just moves to the left, and when we multiply by 10, our decimal moves to the right. So we have the imaginary decimal right here at the end of this number because it's a whole number, and we'll bloop-de-bloop 2 times in because we went 2 times to the left up here. And we get an answer of 75.00 or simply 75 decimeters. So we can say 75 decimeters is equivalent to 7,500 millimeters. All right, that's how we do that. So let's try another one where they want us to do a comparison. So they said, okay, which is bigger, 42 centimeters or 500 millimeters? And the problem here is obviously that one's in centimeters and one's in millimeters. So we need to change one to be the other one. So I'm just going to decide that we're going to change our centimeters into millimeters. So we're going to do our King Henry again, died unexpectedly drinking chocolate milk. We're going to say, okay, if I start here at 42 centimeters, how do I get to millimeters? And so I'm going to actually end up multiplying by 10 one time because we need more millimeters since millimeters are smaller. So I'm take my imaginary decimal, the number 400 or 42, and I'll bloop-de-bloop it over once. Decimal's going to end up there. We fill any spots we have with a 0. We end up with 420 millimeters. So which is bigger, 420 millimeters or 500 millimeters? This one's bigger. Okay, we can do the same thing as all of this, just in a story problem. You end up doing the exact same work. So a honeybee can carry a 40 milligram load of nectar to its hive. How many grams of nectar? So if we use King Henry again, drinking chocolate milk, we're starting with 40 milligrams. And we need to get all the way to grams. And remember, grams is the unit that we're using. So we're going to divide by 10. So we're moving to the left 3 times. So we can take my number 40, imaginary decimal, divide by 10 3 times. So we end up with 0.040, or you could just say 0.04 grams. That's how much you can carry. Okay, so there we have